see, after three very interesting lecture session, now we'll go to the technical paper presentation. All of you must be waiting for it. So first technical paper, adaptation of industrial best practices to achieve world-class maintenance by TVS Motor Hosur. Yeah, may I request you? See, just keep in mind, there are judges who will be judging your. Sir, yes, 1 minute, sir. See, there are judges who will be judging you. Your technical paper already has been evaluated by the panel of 2 judges. Now, after your presentation, again further they will reform, and afterwards only prize will be declared. Your presentation time is maximum 20 minutes. After that, 10 minutes is allowed for a question and answer session. Anyway, you cannot cross 30 minutes. If it is crossed, then there will be negative marking. So, please.
Hi, good morning all. Myself Prasanth and my colleague Mr. Suresh Babu, representing TVS Motor from Maintenance Department. So we'll be taking you through our adoptions of industrial best practices to achieve world-class maintenance. So just a glimpse about TVS Motor Company. We are a $9 billion US company as a group, and we have 16,000 employees across the world. And we are a multinational, of course, and we have 3 million vehicles sales per year and a turnover of 2.4 billion as only as a TVS Motor Company. And our journey is shown here. We have plants in Hosur, Mysore, Himachal Pradesh, and we have a plant in Indonesia also. Recently, last year, we have taken over 3 companies in Europe. One is the 100-year-old company called Norton. They manufacture higher cc bikes of 1000 cc's and above. And we have battery Swiss-made Ego called Ego. That company has been taken over, and one more company is Switzerland. So we are progressing in international markets. So these are all the our portfolios of motorcycles and scooters and 3-wheelers. Of course, EV is also part of the business, and we have a collaboration about 8 years before with BMW. So if any bikes you are seeing entire world with 310cc bikes of BMW, which is only manufactured by TVS 100%. So already 2 lakhs bikes across the world, including Europe and US and Japan. So this is the product portfolio in details, and we are following is a fully TQM company and TPM company. We have got TPM awards in last year, special award. We are also progressing for advanced special award this year, and we are the first company in the world to have Deming award as a 2-wheeler company, and ISO 14000 and all other certifications are here. Also, we got JD Power #1 in the recent years. So these are all the recent products which we have introduced to the market, which is Ronin, TVS Ronin, which is a cruiser bike recently. Then TVS Rider and XL100. This is the legacy product in 1978. The first company has introduced. Still we hold that legacy product with us still. And TVS iQube is our latest EV scooters, and Apache 310, which is in the platform of BMW. So my colleague will explain the further slide.
So our key maintenance objectives are to maximize maintenance effectiveness and maintenance efficiency towards maximize equipment availability and increase zero breakdowns. Also develop maintenance experts. So here through ideal segment map, we have established a comprehensive maintenance system with competitive advantage for business excellence to achieve world-class maintenance practices with our robust maintenance system. We also prepared a KPI-KA matrix to achieve our objectives. So coming to background of the problem, our equipments are increasing year on year with complex automations and robots. Hence our maintenance activities become more intensive. So to overcome these challenges, we followed a below approach to achieve our key objectives. So this is the approach to reduce FTTR. We followed 2 approaches. One is skill development and black box elimination. So coming to skill level journey, here initially we called OEM suppliers for critical breakdowns and unknown systems. Then we moved breakdown support through IT, and again we moved export support through virtual conference. So with this our objectives cannot be achieved. So to enhance our subsystem knowledge, we plan to develop a maintenance skill development center in TVS by our own TVS team. So if you see here, the MTTR is not reducing significantly over year on year. So the competency gap were assessed among the team members in our maintenance team, and 11 subsystems were identified to establish a maintenance skill development center in TVS by in-house maintenance team. So here the teams were formed to establish training modules and aids. We established a skill development center in TVS. So hence it is a unique to TVSM. We given a training more than 4,000 man hours. Also, we developed 42 maintenance experts. With this, our diagnosis time has been reduced significantly by 54%.
Thank you. So this, especially the MTTR aspect, because the background of automations are increasing, sophistication. So this is the step we have taken to reduce the MTTR. So we have, so now this particular training center we are also extending to our suppliers for training them in the particular subsystem what we have done. So based on this approach, next is the black box elimination. So MTTR is well covered in the expert development, and black box is one of the area we are not able to crack actually. There is imported machines, advanced systems. So that is one of major criteria for us to, our high MTTR. So coming to this, black box is defined as based on its input and outputs, but we don't know what is the real thing happening inside. The know-how of the black box is unknown. So to crack that, so for approaching chronic failures in our systems are managed with our approaches in TPM like component model, machine model, then we have PM analysis. But when it comes to the black box, we don't have anything. So in that aspect, so as I mentioned, input and output is there, but we don't know what is happening. So we don't know the working principle. We don't know we have to depend on OEM for any kind of fault findings or repairs. Replacement cost is very high. Diagnostic time is also very high. We have to depend on experts from external agencies. So based on this, across TVSM we mapped different black boxes like electronic printed circuit board, machine elements, which is working principles not explained, customized software, patented products like that. So we identified those black boxes. And one of the example here, we are explaining a particular PCB. For example, we found in black boxes mainly it is related to PCBs, printed circuit boards. We don't have any know-how about it. So in the Pareto we identified the spindle amplifier, especially if you see the CNC systems and servo controls, spindle amplifier is one of the major failure mode in Pareto. And we done this black box cracking by our experts with the help of team, that once spindle amplifier, if you want to repair it, is costing about 50 to 1 lakh rupees. So once we found the alarm based black box elimination aspect, we found only one optocoupler which is costing 500 rupees is failing in the system, and which is cost by, if we give to the OEM, they are charging us up to 1 lakh, and the lead time is 1 week, 2 week time based on their priorities they do. So when we introduced this, we found that it is costing only 500 rupees for us. So we started doing that in a very elaborate way. So we found the significance of that and the cost saving what we are achieving, because we have thousands of CNC machines. We established a very advanced electronics lab with all sophisticated equipments for electronic fault finding. So that's what we have done. By that, our number of PCB servicing hours has reduced to 1 day or half day, and 50% of our cost has been reduced by introducing an electronic lab in-house. So we across the plant we support irrespective of the location. So this is centralized. Then coming to the improving MTTR is addressed here. Coming to the MTBF aspect. So we are vigorously following CBM and RCM. So coming to IoT based predictive maintenance. See, initially we have started deterioration indicators by manually capturing the data with higher-end tools. And later our technicians, they used to capture these data manually collection and putting into SAP system. So SAP system, we have threshold values. They will be entering the values and we will be getting an auto alert through the email system that there is something beyond the threshold limit. And this threshold limit also set in a proactive way that machine will not get breakdown. In a very safe manner, the threshold limits are set that we have enough cushion to act upon. So plant maintenance is well taken care. And CBM, then we found this is also a very good scope, so that we have established a very established CBM lab for this actually. So coming to that, presently we will be explaining the other aspects of it. Yeah, please.
Yes, here initially manual CBM through manual mode. So we prepared a manual schedule. Macro program will run in the CNC machine to capture the deterioration indicators. So these deterioration indicators will be entered in the SAP system against the limits. So whenever there is a deviation with respect to the limit, we will get an immediate mail through SAP system.
So by seeing the possibilities, we established, as I mentioned, vibration analyzer, all the higher-end CBM techniques we adopted: thermal imager, current signature analysis, laser alignment kit, power quality analyzer, and scope. So when we go into details, we understood that there is a big scope. So this is a very unique initiative we have taken as a maintenance team and established the CBM. So further, when we found that, see, the vibration, ball bar, and all these aspects are covered. Further coming to CBM, the manual intervention for CBM data collection is huge actually. Every month people have to go individual machines and collect the data. It is very, as initial presentations we have mentioned, the manpower reduction aspect, productivity aspect. So then we found that the detailed equipments, criticality of equipments, automations, and what is the subsystem criticality. Based on that, the deterioration parameters are captured through installing the sensors. We identified different parameters which are all the deterioration indicators. Based on that, what is the sensor we have to put into the system? This is one of the best example in our vehicle assembly line. As you know, one vehicle loss is also questioned. So particular conveyor temperature is going beyond some limit. So it is set at 60 degree itself. If it goes beyond 80 degree, then only there can be a breakdown happen. So this is email alerts and SMS is coming. Even I can see what is alert in mission. So very critical alerts are designed in such a way that it will be coming to the different levels of people and we can take a permanent measure according to that. Sorry, this is not changing. Thank you. So coming to this, we started making individual machine criticality and automation based on that different dashboards we started making. But we found these different dashboards monitoring is also one problem, so we centralized this. You can see plant 1, plant 2, plant 3, plant 4, everything in a single dashboard. So the individual technician or manager can go, whatever the deep drill down can be done, up to what level, equipment level can be done by this single dashboard, which is comprehensive dashboard we have created. And by this we are about near to 5,000 variables and parameters we are monitoring across the plants. Yeah. And this is the another aspect. When the BS6 era has come in the vehicle, it is one of the mandatory government regulation that the petrol filling has to be taken care. So this, if you see, the petrol filling is one of the very critical process on safety aspect. Online, the petrol is getting filled in the running line with electrical and other sensors and systems. So it is very dangerous to safety. And this particular petrol tank is in 1 kilometer away from the plant, which is lying underground. So from there, the petrol is continuously pumped through the automatic system. So it is very difficult to monitor. So we made a digital twin for that in-house. See, all these solutions are made by our maintenance engineers, not by any other external agency. So that particular core competency of IoT integration is developed by our team. So now our engineers are not only simple maintenance engineers, they are all digital engineers who develop solutions. So these are all the system we can monitor. For example, petrol line pressure, how much it is. If it is going beyond some limit, the total system will shut down. Petrol leak, anywhere any leak. Even I know if a tanker is coming and filling it, if there is some kind of evaporation happens, that also can be known to me. So that is a kind of system, rugged system we have developed. So everything is monitored 24/7. And see, when we are introducing the IoT system, where to introduce, which are all the area we should cover. So as sir told very detailedly, safety will be considered as the last preference, but we are not like that. We give very high importance to our safety.
Sir, TVS cannot. Your Venugopal Srinivasan, he was chairman of the National Safety Council for 3 years.
Okay, sir. Thank you. So safety is given.
TVS is leader in that.
Yeah, TVS because normally the safety systems are not into visibility. Normally, it will be whenever a safety incident happens, then only we will be looking into that. But we cover all the safety equipment live. What is the situation and what is the health of the situation is being monitored here. And so the gas detection system, grid blasting systems, everything we covered in that. This is one of the case study where we are 100% our rotating equipments are with cloud-based vibration monitoring, noise monitoring, and all the aspects are covered in that. This is one of the examples how we identified the bearing failure of a particular rotating equipment and how we proactively bring down the anomalies in the system. And by this, I can proudly say, last 4 years we have zero breakdown in rotating equipments across the plants. And another, coming to the reliability part, we are also very well taken care of the reliability. This is one of the important conveyor we adopted from Denmark. In the design stage itself, as sir mentioned, the bonding failure was very high. We were in a situation that this much crore we invested, we are not able to recover the output and productivity out of it. And we found we have to take it up ourselves. And finally, see, we have changed the design of the conveyor, one of the particular system, but we want to validate it. But how to validate? By putting in the very costly system. So we have taken a measure to develop a reliability test kit. This is first of its kind in maintenance. We have developed a test kit with an accelerated testing of this design validation, and we proved that this particular test kit is running, that particular design is running from 0.83 kind of reliability, from 0.4 kind of reliability. So that is also being done. And this is also one of the very critical equipment, ABS filling, 125cc and above, everything is coming with ABS filling now. So this is an important machine. We have very frequent failures of piston, 24 lakhs one regulator filling system, if you see. So that piston was failing, and with the OEM help, we have developed a piston which is, we saved about 24 lakhs by reliability method. And coming to power and air, this is one of the major energy guzzler in our plant actually. We also look into that. With the total power and air consumption system, line-wise, we have IoT sensors, and we know even if a flow is increasing in a particular line, immediately the leakage corrections and other aspects are being taken. And everybody can monitor the total lighting system of the plant through mobile, and the automatic cutoff systems and things are. And one more thing in TVS, some of our plants are 100% sustainable energy using company. So that wind and solar. So 85 to 90% other plants, now only 15% of the part is taken care. Within coming years, we will be 100% sustainable energy aspects. And year on year, we are reducing our cost of power and air. And this is some of the digitization of our standardization aspect. Total Kaizen and FTA, fault tree analysis is being digitized. And we have a ECM target also for achieving all these. So we continuously motivate our team to come out with new FTAs and Kaizens. So these are all the equipment note, IoT architecture, design FMEA, and MSDC manuals, lab e-learning, everything is standardized digitally. By all these implementation, we are reducing our MTTR continuously and world-class level of 20 minutes presently. MTBF is improving year on year altogether. Then R&M cost per vehicle is reducing at 43 rupees per vehicle, and power and fuel cost is drastically reducing year on year by this implementation up to 14.4 to 13 units per vehicle. And this is our ongoing projects. We are not stopping here. We found some of the cartridge spindles and systems are very difficult to manage. So we are developing an in-house servicing system for this. And these are all the AI maintenance we are going. All the data what we are capturing is getting artificial intelligence programs we are developing. And the way forward is presently we are working on vision-based critical equipment monitoring, which is already completed, analytic-driven decision making, and scheduling the maintenance through IoT, and virtual maintenance expert is the final destination what we are looking for. Thank you very much. Yeah.
Thank you very much. Very good presentation. Of course, judges will decide. Only one question I can take. Only one question. Anybody has question? Judges?
I think only one question, since we have put a cap. The question is very, not the question but a comment. It's very commendable effort when you are talking of black box, and as I could see, out of 400 odd number of PCBs, almost 372 or something like that. 372, you can set it right. It's quite remarkable. But this technology now you monetize, sell it to others also. Why you want to keep it to yourself?
Yes. Yes.
And give the royalty to me for this. Thank you.
No, sir. See, we are also, as I rightly mentioned here, our training facility now we extended to our suppliers on a cost basis.
Yeah.
Our maintenance engineers are now, as I told, digital engineers. At the same time, they are professors in our maintenance and development center. So that is how our progress is going on. And supplier, they are paying us for training and other developments. Even PCBs are coming from suppliers to service it.
No, but this you are still limiting to suppliers. I am saying expand it further.
Okay. Thank you.
To the competitors.
To the competitors as well.
Sir, actually here we are doing a reverse engineering. Actually based on the alarm, we are decoding the problem.
We understand.
Thank you very much. We understand. And during lunch break, definitely we will like to interact. So.